Assalamualaikum and hi. For this presentation, our our team would like to present about our finding about foundation engineering. So we are group 3 and group members are Hamim Daniel bin Hartika, Muhammad Izwan bin Muhammad Zaini, Ahmad Hakim bin Ahmadul Kamal, and Ramsa bin Alam and Muhammad Alif bin Tamiha. For this presentation, we are going to present about master plan study on the construction and development of Sekolah Menengah Kebangsaan Tanah Merah 1, Tanah Merah Kelantan, and developed by Beta Engineering Consultant. And here is our company logo. For company organization, board of direction is Hamim Daniel, project manager is Muhammad Izwan, engineering manager Ramsa, consultant engineer Muhammad Alif, and site engineer is Ahmad Hakim. Company background. Beta Engineering Consultant is a dynamic and innovative foundation engineering firm based in Kuala Lumpur, Malaysia. Our team of highly skilled engineers, geotechnical experts, and construction professionals are dedicated to providing comprehensive foundation engineering solution for a wide range of projects. For our company mission is to deliver superior foundation engineering solution that exceed our clients' expectation. For our company vision is to be recognized as a trusted leader in foundation engineering, both locally and internationally. For objective of our study is to accommodate client demanding requirement and highest expectation, most functional, safe, least cost, and minimum maintenance design. All work will be carried out in a professional manner.
Assalamualaikum. My name is Hamim Daniel bin Hartika. My metric number is CF200105, and today I want to explain about the project description, which is site investigation. So, site investigation plays a crucial role in foundation engineering by providing essential information about the soil and subsurface conditions at a specific location. Besides that, by conducting a thorough site investigation in Tanah Merah Kelantan, which is our project, the foundation engineering team can gain valuable insights into the site's geotechnical properties and make informed decisions during the design and construction phases. And this ensures the foundation system is well suited to the soil conditions. And the next one is field exploration and testing. The first one is standard penetration tests in soils conducted at regular intervals of depth. Samples of disturbed and undisturbed soil, two different kinds of samples were gathered. Disturbed samples, which is suitable for testing index properties and for identification at varied depths. And for the undisturbed samples is for the strength evaluation. As you can see, this is equation that we use for our project. N60 is represent the corrected SPT N value for the field procedure. EH is the hammer efficiency, which is can refer the table 2.1. CB is borehole diameter correction. Also, we refer the table 2.1. And CS is the simpler correction. Also, we refer the table 2.1. N is measured SPT N value in the field. The next one is the correction due to the done irrespective of type of soil. SPT hammer efficiencies, BNBC 2015, table 6.24. This is the table of it. And this one is the borehole sampler and rod correction factors, BNBC 2015, table 6.25, which is the F3 section, borehole dia factor CB, sampler correction SCS, and the rod length correction SCR. The result is in the table below. As you can see, this is the formula for the angle of friction, where N60 is represent the field standard penetration. Meanwhile, this is the soil profile. For the top of it is silty clay, and the second one is the sandy clay. The third one is clay silt, and the last one is the sandy silt, which is represent the more and the most biggest in the soil profile. For our group project, this is the table 3.2 summary on ultimate axial load, which as we had 5 group Group A, Group B, Group C, Group D, and Group E. And table 3.3 shows the group of loads as shown the figure above. Group A represent the 599 kilonewton, B 999 kilonewton, C 1199 kilonewton, D is 1699 kilonewton, and the E is 2400 kilonewton.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hakim bin Ahmadul Kamal, and this is my part, which is design for foundation. Designing a solid foundation is essential in building construction to ensure the effective transfer of load from the building onto the ground. The foundation is a critical component of the structure, supporting and acquiring the superstructure while transmitting its load to the earth. To create a reliable foundation, several factors must be considered, including determining footing, depth, and spacing, selecting an optimal location, accounting for displaced soil, addressing erosion near flowing water, and more. Each of these factors is crucial in creating a foundation that offers stability, safety, and long-term durability for the structure. We have chosen a shallow foundation for selection of foundation. We have chosen a shallow foundation approach for our project design. Especially, we are using spread foundation, which is cost effective and distribute to the building load over a larger area, reducing soil trees. We have employed the Tizagi method to calculate the design parameter using soil information from table 4.1 to accurately assess the soil characteristic and ensure a properly designed foundation. For the example of the calculation, I choose group B, which is 600 kilonewton to 999 kilonewton. The soil properties were given taking from table 4.1. The shape of the foundation is square. When a square shape mean that B size is equal to L size. For the shape equation, the first step is we need to find the FCS, and the formula for FCS is equal to 1 plus B over L multiplied by NQ over NC. Secondly is FQS equal to 1 plus B over L and multiplied by tangent theta. That is FYS. The equation for FYS is 1 minus 0.41 plus B over L. After shape, we need to find or design the depth of the foundation. For the depth equation to be equal to dF over B must be less than 1. For theta larger than 0, we need to find the FCD, and the equation for FCD is FQD minus 1 minus FQD over NC multiplied by tangent theta. Okay, last but not least, the inclination. The inclination formula already state, which is need to solve all the QU equation, and it is fixed for this selected for foundation. The amount of FCI, FQI, and FYI is equal to 1. After got solve all the QU equation, the next step is to find out the QAll, which is the equation is bring back the value of QU and divide by the amount of the safety factor. Then apply all this value pressure to the ground to find out the amount of B. Therefore, the size of the spread foundation for group B is solved. The result of the calculation size of the foundation for each group member state in this table, which is group A 100 kilonewton to 599 kilonewton is 0.8 meters, and group B 600 kilonewton to 999 kilonewton is equal to 1.0 meter. That is zero group C, which is 1000 kilonewton to 1199 kilonewton. Got B size is also 1.0 meter. The fourth one is group D, 1200 kilonewton and 1699 kilonewton is 1.3 meters. And the last one is group E, 1700 kilonewton to 2400 kilonewton. Got the B size equal to 1.6 meter. Okay, that's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Ramsa bin Alam, and I will explain about the checking of settlement of the foundation. So, based on the calculation performed, it has been determined that no settlement are expected in Group A, B, C, and D of the foundation. However, settlement is predict to occur in Group E, and the calculated settlement value exceed the allowable limit. Considering this finding, it is essential to implement measure to prevent settlement in Group E and ensure the stability and longevity of the structure. Foundation improvement technique can be employed to address this issue. This technique may include soil stabilization method such as compaction or reinforcement, or the use of specialized foundation system such as deep foundation or ground improvement technique. By implementing appropriate foundation improvement measure, we can mitigate the settlement issue in Group E and ensure the foundation capacity to support the building without compromising its structural integrity or causing any undesirable consequence in the future. So this is the example of the calculation to find the settlement of each group, which is Group A. We get 9 meter, and then convert to millimeter, which is we get 9 millimeter, that less than 65 mm, so it's okay. And then for Group E, we get 77 millimeter, which is more than 65 millimeter. So the settlement occur for Group E. That's all from me. Thank you.
Assalamualaikum and very good day. My name is Muhammad Izzuan bin Muhammad Zaini. I'm in Senawi SCF 200 and 40. So I will present about the discussion from our group for this project. First is our group suggests split footing as our foundation design. The soil parameters obtained from the block, and the soil for this project is clay soil. And the loading from column transfer to foundation are 100 kN, 600 kN, 1000 kN, and 1700 kN. And the proposed size are 0.8 meter times 0.8 meter, 1 meter times 1 meter, 1.1 meter times 1.1 meter, 1.3 meter times width 1.3 meter, and the last is 1.6 meter times width 1.6 meter. Our group also recommend to use deep foundation rather than shallow foundation to ensure structural safety. Even though deep foundation is more expensive rather than shallow foundation, but our group suggests to use deep foundation rather than shallow foundation. And the objective for this project is to improve our abilities and knowledge in the field of geotechnical engineering, and also to use the knowledge that gained when applied in future practical work. Next, I will present about the appendix for this project. So there are two types of appendix for this project. First is Appendix A, show that the SI report of block analysis for this project, and also Appendix B show that the plan of building for this project, and also the design of foundation for this project based on the calculation that our group did. So that's all for me. Thank you. So that's all from our group explanation about the calculation and also the design of foundation for this project. So that's all from me and our group. Thank you.